Good evening, everyone. So I think last time we started with a brief introduction to ECA Act and then Energy Efficiency Building Code, ECBC and ENS. Probably today we can have we can start with an overview of the star rating programs, and then we'll go into a bit detail into ECBC. I'll cover the envelope section today and maybe lighting, which usually falls under the scope of the architect. And tomorrow, my colleague Arun, who's a HVAC MEP specialist, he will do a session on the comfort systems, HVAC section, electrical, and other the rest of it. Okay. Is my screen visible?
Yes, madam, visible. Clear.
Okay. So we all must have seen, like, if you go to buy air conditioner or a fridge, we would have come across a rating system, like a star rating, star for the product. Either it will be a 3-star rated product or a 4-star rated product. And what it kind of implies is, if it's a 4-star rated product, it means it's quite an energy efficient product. It consumes less of energy. So when we go for a 4 or a 5-star rated product, our energy bills are going to be less because it's quite energy efficient. So the same concept has been the star rating has been the same labeling system. Bureau of Energy Efficiency wanted to extend it to buildings as well. Okay. So the concept is, if probably we are looking to buy a car, okay, the first thing what we will see is what is the car's mileage. Okay, so when we say mileage is like, what is the distance it covers for if you fill it with a 1 liter petrol in the tank. So we calculate the mileage. So for 1 liter petrol, this is the distance it covers. So the similar concept only, we calculate the energy performance index, or we, in the short form, we call it EPI. Okay, so based on the EPI, buildings will be given a star rating system. Okay, so the first, the Ministry of Power launched it in 2009 for commercial buildings. But when I meant commercial buildings, the program was applicable only for office buildings, BPO, and shopping complexes and hospitals. Okay, these are the 4 sectors of commercial buildings where the star rating program is currently applicable. Maybe in a couple of years, the data centers and hotels will be included. Okay, and recently, I think 2 years ago, they also launched the residential star rating system. So the star rating program, as I said, is based on the energy usage in a building, okay, over its area expressed over kilowatt of energy per square meter per year. Okay, so based on the program, we have a rating from 1 to 5 scale, with the 5-star being most efficient. So as I said, right now we have it for office buildings, BPOs, hospitals, and shopping malls. And the upcoming labeling program will be for hotels and data center. So to apply for a star rating system, and the building should have a connected load of at size of the building should be around 100 kilowatt. This is for the earlier program. I think January 2023, Bureau of Energy Efficiency has revised it, and even smaller buildings, office buildings, are applicable. Okay. So either the building owner can register either manually or electronically, and they can submit an application form to Bureau of Energy Efficiency, and an energy audit will be conducted based on the details submitted. And after clearing the energy audit, the Bureau of Energy Efficiency will issue the rating star rating, which can be displayed in the premises. The initial period was 5 years. As I said, in 2022 January, they have changed the norms. So the period label applicability is for 3 years as of now. Okay. So there is this is a voluntary program. Okay, this is not a mandatory program. The reason why star labeling was introduced was because one, it wanted to Bureau of Energy Efficiency wanted to create awareness to buildings to see how much of energy they are consuming, and there should be a benchmarking for that. Okay, to see if the building is really efficient or not. We all consume, we all take measures, we do audit, we do like use energy efficient products, LED lighting in design wise. But there has to be a benchmark or a standard to see whether what we have been doing is impacting or it's effective. So the benchmarking system is there. And right now it is a voluntary program. It's not a mandatory program. The star labeling is voluntary program. And there is a registration, one-time registration fee for application. So for large office buildings, as I said earlier, they had a connected load. Now they have removed the connected load. So for larger office buildings up to more than 30,000 square meters, the cost is 1 lakh per project. For medium-sized office buildings between 10,000 square meter to 30,000 square meter, it is 75,000. And for smaller buildings, it's 50,000 one-time fee. And if there is a renewal or upgradation, there is an extra 25 to 15,000 fee. Or if there is just if you're just renewing it without upgrading your star, then there is a slightly difference in fees. So as I said, how do we calculate? Okay, so we do calculate the energy performance index, or we call the EPI. So it's very simple. We take into consideration the annual energy consumption of the building divided by the total built-up area, excluding the unconditioned basement. Okay, so based on that, we get an EPI value. And then that EPA value has various parameters for the star rating calculation. So depending upon the climate zone, the EPA values for rating system will differ. And as I said, also depending upon the size of the building and the condition area. So Bureau of Energy Efficiency, until last January, they had a very simple thing. So you calculate only this EPI and then match it with the number given for the in terms of for warm and humid climate in Tamil Nadu. If the EPA matches 100 or something, then you get a 3-star. But now they have revised it, streamlined it, and made it more efficient. So they have introduced parameters. Okay, so this is the way the star rating will be calculated. So first you have to decide under which climatic zone your building falls under. Currently, star labeling is not applicable for cold climate. So we have for composite, warm and humid, and hot and dry climate. So only 3 climatic zones have a star labeling program. So first you have to make analyze where the building is. So if it's in Chennai or somewhere in Tamil Nadu, it will come under warm and humid climate zone. And then based on the building category, whether depending upon the size of the building, we have to decide whether it's a medium building or small office building. And then the calculation, it's kind of, a reverse calculation. So for example, sample calculation I have shown. So the electricity consumption, okay, for office building, which we have assumed is 100% conditioned, meaning the total office building is 100% AC. There is no complete air conditioned office building. So we have for the 12 months, we have the electrical consumption in kilowatt per hour. And we have the size of the built up area of the office building as around 13,000 square meter. And then the EPA calculated here is 149.3. Okay. And the conditioned area X is 100. So based on the calculation, Y is equal to, as from we get the calculation when we go see, so warm and humid, the calculation will be Y is equal to 0.9x plus 65. So we do a trial and error to see which one fits into this. So based on that, if you see, if we calculate plus 65, closer to it is 155. Okay. So when we go with that number, then we match it with the EPI. So 155, it is matched under 1 star. Okay. In fact, this is the calculation of the Tangentco building, Transco new building, which we did. We thought probably it was a new building and it will get a better start. So we wanted to go for a star labeling application. But when we calculated, we came to know that the building's performance is only 1 star. So this probably gives, as a building owner or a property manager, an insight to where they stand and probably an opportunity to do energy audits or to see where it can be, where the energy consumption is going more and how to reduce it and take some steps. And the other reason, a lot of buildings, especially office complexes, go for star labeling is because when they are 4 or 5 star rated buildings, they are able to attract tenants. Because everyone will know the same concept. We buy a 4-star AC or a 5-star fridge. The same concept. People will think, okay, this is a star-rated building, 4-star rated building. My energy bills won't be very high every month. So that it is. And one other big difference between BE star rating and all the IGBC green ratings. Even IGBC buildings which have got platinum rating in the green building rating system, sometimes through research have shown have failed in the Bureau of Energy Efficiency star rating system. This is because that is an simulated value. Okay, so that is a value based on assumption. But here we can get into calculation the real value which we are consuming. So this is a more gives more clarity and a more real value as compared to other green building rating systems. So for the process of star labeling is very simple. There is an application form for participation and agreement where the building owner or the property manager or the person in charge can sign an agreement with the Bureau of Energy Efficiency by submitting a DD application payment fees in favor of Bureau of Energy Efficiency. And this is the main energy data, building information and energy data, which has been collected for giving the star. So basically, as I said, the connected load or contract demand for value. So the star rating system would be based on the connection. So if you have a 100 kilowatt or whatever connection, one connection, and you are using it for 3 separate buildings, then you can do one payment of fees and get it for a rating system for all the 3 buildings. So it is based not on the building, it is based on the connection. So it depends upon which, if for IT offices, sometimes there will be one connection for serving 4 or 5 offices. Then all the 5 buildings will get the star rating if we apply for one application. So, and the other thing is the renewable energy you are using is not taken into account. Okay. Which is a good fact, because if you are using renewable energy and then of course your electricity consumption bill will be low, so the chances of getting a higher rating based on the EPI will be there. Okay, so these are the basic details which are required: the annual consumption, the installation capacity for a DG set, the electricity from the grid, what is the electricity from the other sources, and then the type of the building, like, if the building is operational from 9 to 8, or what are the timings, how many people, what is the built up area, and then the air conditioning system. Usually the lighting and air conditioning system are the main energy consumers in the building. So if it's going to be a split AC, what is the conditioned area space? If it is a split AC, then what is the capacity and how much? Or if it is a install lighting load, what is what type of lighting and what are the details, and any other major loads in the building. And based on then all this information, these 17 points, you can apply for the calculate the EPI, and based on the calculation, sign in an agreement with the Bureau of Energy Efficiency and apply for the label. So it's a very simple, straightforward application. The application is very simple. These are the details which are required. And once you fill in the details, then you sign this agreement form with Bureau of Energy Efficiency. And with that, submit your DD. Then Bureau of Energy Efficiency sends usually NPC for energy audits. This audit is only once a year and not every year. So it's a one-time audit, and based on that audit, the star rating will be awarded. Yes, so as I said, the label verification process will be done by Bureau of Energy Efficiency, and then the label will similar. It's a very similar label to the one we see in our fridges or ACs. The similar ratings is star labeling will be awarded, which can be displayed in the building. So that's about the commercial star labeling. Any questions on that?
Yes, ma'am. So actually, you are calculating with a factor, right? Can you explain it again, ma'am? So like.
So the other is, as I said, for residential sector also, the Bureau of Energy Efficiency has introduced a similar labeling program, which is slightly different. For commercial buildings, the building has to be operational for at least 1 year because we need annual consumption, meaning 1 year's consumption. So it has to be a building which can be a 20-year-old building, 25-year-old building, doesn't matter, but it cannot be a newly constructed building. It has to be operational for at least 1 year. But for residential labeling system, there is no such thing. You can even go for applied label for a building which is already being constructed. So as you see, the electricity scenario, that 33% of buildings electrical consumption is by residential and commercial building. And if you see in electrical consumption, lighting, HVAC fans, these are the mostly like it's. So if you see in commercial, lighting and HVAC are the biggest energy consumers, and in residential, probably fans are the ones. So that's why Bureau of Energy Efficiency has recently launched the BLDC fans, or labeling system even for fans, where you can look at the energy efficiency of the fan, and then when you calculate the service factor, then you can find out the energy efficiency, and you can choose a energy efficient fan. So this is the residential electricity consumption versus area. So on the projection, if you see, there is an increase in almost 8% in increase every year annually on the electrical consumption. So the need for the labeling program was to making energy efficient homes, tackling the consumption in the residential sector, and then also helping us make an informed decision while buying or leasing a house. And then also it's a step forward from Econova Samhita. Econova Samhita, as we saw last time, is the energy efficient building code for the residential sector. So it is more, so mostly if you build according to Econova Samhita, then the star rating which your building will get will easily be a minimum of 3 or 4. So this is the residential labeling program, similar to the commercial label. You also get a building passport, which is like a passport for the building. On a national level, the objective of the labeling program was to bring about energy sustainability in India and also achieve the Indian NDC target. So to bring about some transformation, some awareness, for us, we can check whether we are consuming too much electricity in the house, or where do we stand. So people can make a choice. And as I said, for residential star building, even at the when it's at a construction or design level, based on what type of material, what you're using, the construction details, and those details, you can calculate for a label, and it is called applied label. So the reason for an applied label is, in the real estate market, as we see, there are like a lot of properties available for sale, a lot of inventory of apartments, and when people are looking to buy, so if the builder has gone for applied label and given and achieved got a 4 or 5 star rating for the building, then the consumers can choose an offer to buy such apartments. So, and then also peer-to-peer confirmation, and also provide information on potential and actual energy use of buildings. So as I said, the residential label, you can go for new houses and also existing residences. And for residential labeling program, there is no minimum requirement that it has to be this much, area of connected load or this much square feet. Any individual house, it can be 100 square meter or 300 square feet also, can apply for a residential star labeling system. So the star rating again is based on the energy performance index, and the energy performance index is calculated with the annual energy consumption divided by built-up area. And for this, Bureau of Energy Efficiency has an online platform or an application tool. Okay, so it's easy to apply. So you can open the tool and input all the required details in terms of what is the material of construction, what is the glass. There are a lot of details. It will ask the size of the building, the rooms, how many windows and window size, and all those details. When you input the building, then automatically that will calculate the EPI. So the online platform has a simulation-based tool which will be used to calculate the EPI for the respective dwelling unit. Whereas in commercial, we are using the live data, the energy consumption data, to calculate the EPI. In this, we will be using the simulation tool to calculate. So we can go for applied label, and then later when the building is constructed, we can change it to final label. So, and then we can also transfer the label. So if a builder applies a label, when a builder applies a label, then and as a person is buying the property, like how the property is transferred, the building label will also be transferred. Someone had asked, what is the peer-to-peer comparison? In meaning, we have, as I said, a lot of builders in the market. In Chennai, if you see, we have Apasami, we have Ramanian and everything. So we all know in terms of the quality of the building they built and everything, but we were not able to evaluate the building based on energy efficiency. So this would give them a comparative, okay, probably which buildings are more energy efficient, which are the buildings where they're getting 3-star or 4-star. So we can know where in the market they stand in terms of and from the energy efficiency point of view. So the applied label can be applied during construction. Once the construction permit is issued, then you can go and apply for the applied label. This is the applied label is mainly for real estate builders, so that they can use the applied label system, get the star rating, and then they can add it in the advertisements. So as a selling point to the consumers. And then when the occupancy certificate is obtained, then you go for the final label. But for an existing building, you can directly apply for a final star labeling. So again, as I said, the star rating is awarded on the basis of energy performance index, and the energy performance index or the mileage is calculated using annual energy consumption divided by built-up area. And for residential EPA calculation, we take into consideration the air conditioned space uh, with the assumption it is set point at 24 degrees centigrade as E1, and then the other spaces as natural ventilation, and then the appliances used. So in the online application tool, you will be kind of inputting all the details, how many fans, how many lights, what type of lighting, or if you're using a star rated product, then that information, everything will be you will be inputting in the tool, and then based on that, it will simulate and calculate the EPI. So again, the performance indicator, EPA or any other indicator, if it's a 1-star, means the project qualifies for labeling, minimum eligibility criteria is fulfilled. 2 to 4-star means a better performance from the baseline will be demonstrated. Okay, so 2-star, 3. And if it's a 5-star building, then it probably a building which kind of demonstrate exemplary performance. It is almost like, most net zero buildings would be 5-star rated or equivalent to that. So again, the star rating system also, most of ECBC or Bureau of Energy Efficiency codes and the rating system are based on the climate conditions. It's divided into 5 climate zones: hot and dry, which we see in the red, the Rajasthan and the areas; warm and humid, which is all the coastal lines; and the middle part of India, which is most composite. And temperate would be Mysore, the ones on the like Mangalore, Mysore, those kind of things. And the cold climate is probably in Tamil Nadu, Ooty, Kodaikanal, and in the northern part, Karnataka. So based on these, as I said, we don't have the star rating for cold climate. The other, the EPA values for climatic zone differs. So for warm and humid, if you see, we get for a 39, we get a 3-star. Okay, so whereas in a temperate, it's more stringent. Something which is between 21 to 24 gets a 3-star. So based on the climatic zone and the EPA, the stars are different. So upon approval from DE, a building passport will be generated based on the details of the label application, and the soft copy of the passport will be auto-emailed. So this passport will have all your information: who's the owner, who's the applicant, when was what is the project address, what is the EPA, when was it applied, how long it will be valid, and all the calculations will come in the thing with the digital signature. And also a plaque will be provided to the applicant, developer or the owner for the residential building and approval of the final label. Okay. So once you get the plaque, if you get a 4 or a 5-star, probably most owners would like to display it proudly. So that is the plaque is for display in the public. And then even for the plaque, there are 3 different sizes. The cost depends upon the size, but not much of difference. Something between 2,000 rupees to 3,000 rupees is the cost between small, medium, and large. So again, same, you have to, the application process is simple. So you get a letter of award with the details. These are the details will be provided in the passport. So basic information and label information. So the application process is user registration, and then you go, the property registration is done, and then the application submission for dwelling unit, and after scrutiny, the final label is awarded. And if, as I said, if it's a developer, he can do it and then do a transfer of label. So these are the 2, the way how it is done. from application process, you log into the portal and then apply for the label. And then once it's done, you get a simulation report. And if it receives the API, then you make a payment. If it's something what you want to go, if you get a 3-star or a 4-star, if that's what you want to go, then you do the payment and get the thing. And based on the application reference number is also provided. So at the scrutiny stage also, here, because it is a simulated one, there is no audit or anything. Based on the data inputted into the application tool, the simulation is done. So that is how the label is awarded. The fees for star labeling for residential is very less. As you see, for a dwelling unit up to 100 square meters, fresh applied label by the developer is only 2,000 rupees. And then for every 100 square meter increase, you will have just a 5 rupees 5 per meter square. So it is and for the transfer of a label, it's also 1,000. So even if anyone is interested in, applying a label for your individual residence, where it's your own house or apartment, you can go and I think within less than 5,000 rupees, you will be able to get a star labeling with the plane. So as I said, for the final label with the small plaque is 2,500, the bigger one is 3,000. And then for transfer details, there is a 1,000 rupees fee. Compared to commercial labeling, the star labeling residential fees are very, very less. Again, the validity of the label for a applied label, new construction, 3 years. Then after you first apply for applied label, and after 3 years or after completion, when you get the OC, you can get a final label. And after that, the validity is five years. For existing construction of a building which is already constructed and up and running, then the final label is for 5 years. So this is in terms of just a brief on how is the transfer of labels can be done from developer to owner or owner to owner. It's all the applied label cannot be done in some cases, but the final label will be done. So for this is about how for apartment, we will have 1 bedroom, we'll have 2 bedrooms, 3 bedrooms. So it will be a mix of all bedrooms. So how the calculation is done is based on the distinct architectural layout, then orientation and exposure to the sun, which side it is facing. So probably if it's a front facing east facing building unit, then the EPA will be different from a back or west facing unit, because the heat entering from the east will be less from the west. So the distinct built-up area also, and then the boundary conditions, whether there is a ground next to it, the ceiling is exposed to sun or not. For example, we all know a top floor house, the final floor is usually much hotter compared to a lower floor. So all these considerations are taken while giving a label for that. So that is about the residential star labeling thing. I think in Tamil Nadu so far we haven't got any residential star labeling, because Bureau of Energy Efficiency has recently introduced this program. So I don't think that anyone has applied. I'm not sure, but at least through our state designated, no one has applied. They would like to promote it to builders, as I said, so that can be used as a selling point, like how we choose air conditioners which are 4 or 5 star. Soon we will have a choice to choose a 4-star or a 5-star rated apartment building when we are looking to buy or even to rent. Okay. So this is a very interesting and much needed for the residential sector. It might take some time to start, but once it is, I'm pretty sure all apartments listed in Magic Bricks or all similar website are going to probably showcase their rating system, star rating as well in the future. Any questions on the star rating program for residential?
Madam, any commercial or hospital hospitals holding
If there are no questions on the star rating, I'll quickly go to ECBC awareness.
Madam, excuse me. Can you hear me?
So were all of you present in the first class where we had introduction of ECBC?
Ma'am, actually, you are
I'll
audible,
just
ma'am.
briefly go through the ECBC scope and applicability. So the Energy Conservation Building Code, in short form, it is called ECBC, was formed in 2007. The first code was done, and then later the amended or the edited final version was published in 2017. Okay, so this the reason for the code was, as we saw, buildings consume 33% of energy consumption in India is from the building sector, and there had to be some regularization to reduce this energy consumption and also pave way to net zero. So to do that, the ECBC code was formed, and a lot of states, I think 19 states have implemented or notified the code. Andhra, Telangana, Kerala have implemented the code, and all commercial buildings are following. In December 2022, last year, 27, Tamil Nadu has notified the ECBC code to make it mandatory. The implementation process hasn't started. Maybe if it all goes well in a year or two, even it will be mandate. Tamil Nadu will set up the implementation process, and all commercial buildings which fall under scope will have to show ECBC compliance for building approval and occupancy certificate. So the applicability of the code is any building which has a connected load of 100 kilowatt or a contract demand of 120 kVA, and it's applicable to all commercial buildings, meaning educational, healthcare, hospitality, business, shopping complex, assembly. All these buildings come under the purview of ECBC. The exceptions would be manufacturing processes, which use electricity consumption for manufacturing. And if there's any safety, health, and environmental codes prevailing, need to be then those prevail over this. So Tamil Nadu, the scope of ECBC was slightly altered. We have included a built-up area of 2,000 square meter in addition to the connected load or and contract demand. So it's either or condition. If the building falls into one of this, either a connected load of 100 kilowatt or a contract demand of 120 kVA or a built-up area of 2,000 square meters, even if it falls under one of the criteria, it will come under the scope of compliance. And then Tamil Nadu falls under two climatic zones. As I said, the code is primarily based on the climatic zones of India. So Tamil Nadu predominantly comes under warm and humid climate zone. Ooty and Kodaikanal will be only the cold areas. So the applicability on building components. Okay, so the ECBC kind of is applicable to the whole building set as well. Especially when it is a commercial building at that scale, if it's going to consume 100 kilowatt or it's going to be a 20,000 square feet of building, then we will have specialized people to design or consult for each and everything. Of course, MEP will be a different department than HP, in terms of lighting consultants will be electricity, So probably there will be an architect to design the building. So taking into consideration, the ECBC kind of proposes an integrated design solution. So it is not in scope of one person. Probably it lies into, or it's an integrated design where there is a chariot of architect, MEP consultants, electrical consultants, lighting consultants, builder, everyone kind of in the same page, and then design and execute the project, then only it might show compliance. So building envelope is the features related to how energy can be reduced using the building envelope features. Then comfort system controls and HVAC is one component. Then lighting, then there is electrical system, then there is renewable energy. And for very, very large buildings, we have controls and other systems, applicability for controls and other systems. So the building envelope component or components of the building envelope. So what is a building envelope? So if you see, like, in a building, we have a roof, we have walls, we have foundation, and then doors and windows. So this is all the outside part of the building, like, not the interior part. In the exterior, we'll have the roof, walls, windows, and doors, and the foundation. So these all together, like, are called a building envelope. A building envelope consists of a wall assembly, window glazing, foundation, roofing system. It provides a physical barrier between the exterior and interior environments. Okay, so a building envelope accounts for approximately 30% of energy consumed in residential and commercial buildings. Okay, it plays a key role in determining the levels of comfort, natural lighting, ventilation, and energy efficiency. Because if we saw in the previous slide, energy consumed in an office building is mainly due to air conditioning and lighting. Of course, other office laptops or equipments will fall under, but the main gulfs of energy are like, air conditioning and lighting. Same way in a residential building also, is fan and lighting system are the main. So why do we need if we have to reduce this these two components, we have to look into design to reduce our need or dependency into having an AC and also on the lighting. So how do we can come about is where the building envelope features come. So when we are using AC to cool a building, okay, because the building is hot inside, we are using an air conditioner to cool the building. But how does the building get hot? Because the outside temperature is hot and there is transfer of temperature, transfer of heat from outside to inside. We all know, we have studied in, in physics, like, heat, there is transfer of heat to conduction, convection, and radiation. So through all these means, when there is a difference between the temperature, there is always a transfer happening. So if probably we know in Chennai, okay, in summers it goes up to 40 degrees, okay, then that heat is going to penetrate into the building. And to once it's penetrated, the interior or inside of the building is also hot. So we need to cool the building. So we are using an air conditioner. Okay. So when the heat is getting transferred, there is also a rate at which it is passing, from outside to inside. Okay. There are materials, like every material will conduct heat. Okay. Some materials will conduct it quickly. Some materials will offer resistance and do it slowly. Okay. So the heat conduction which happens, what we call is called the U value. Okay. The thermal transmittance of heat is called the U value. So if we can choose a property of a material where the U value, the heat transmittance is low, then we can probably reduce the heat coming inside. Okay, it's going to be slowly. So the building is not going to be heated too quickly. So our consumption, energy consumption for HVAC or fan is going to be less. So if you see in those days, like, especially in Rajasthan and all, the walls will be very thick, like, 2 layers of walls. Because once, by the time morning, like, around 10 or 11, the heat starts coming inside, and then it will take time to slowly pass through. And then by the time it reaches the middle part, then after 4 o'clock, the temperature drops and starts cooling. So then it goes back. There's the heat is dissipated and it's not coming fully inside. So that's why in those days, especially in hot and areas like Rajasthan and all, the walls used to be very thick. But now when we look at it, we can also have those thick walls, the concept. But we are running out of space. Each, square meter or the built up area, people don't want to lose it. Okay. They want to go for thinner walls inside because then they have more internal space. So every square feet or square meters calculated is has become so costly and expensive that we have to make the maximum use. We cannot use the concept of double walls. So to do what in that case, what we can do is that to limit the U value, the heat coming inside, we can use materials which have low U values. For example, concrete has a very high U value. Brick has a normal U value, and as per research, AAC blocks has less lower U values. And I'm not sure if you have heard of porotherm blocks. So the porotherm blocks have very, very low value because there's insulation layers in between or gap in between. So one thing what we can do is reduce the U value. And then when it comes to fenestration, so fenestration, we mean any opening in the wall is called a fenestration. So that could be a door or a window. So again, from outside to inside, there's a barrier. It could be a wall or it can be a door or a window. Again, there is heat transfer. So if we can limit the heat transfer through the door or window also, we can reduce. And the other one is the roof. In fact, there is proof that 50% of the heat transmitted inside a building is through the roof. That's why we have experienced in apartment, if you go, if someone is living on the top floor, especially in summer, the house will be very hot because most of the time when the sun hits 12 to 1, it is exactly 90 degree and it is the time when the sun rays are very strong. So it hits the roof exactly at 90 degree and there is penetration inside. So if we can maintain the U value to the value prescribed, then we can, by following, reducing these U values, we can probably reduce the intake of heat into the building. So as I said, the thermal transmittance or the U value for the roof, is the roof which can be used as single material assembly or it can be limiting the U value helps in heat gains or losses. Okay. For a cold climate, probably you would not look into using insulation for roof because during cold weather, then you can, if you're predominantly a cold climate, then you don't need to, probably you would like to increase the U value. But in places like Chennai or Tamil Nadu, we would like to reduce. So one option is kind of using, keeping the thermal value by using any type of insulation. It can be a weatherproof or natural insulation, construction insulation, or although as per standard, ECBC doesn't set clauses. The other options recommended in ECBC are cool roof and vegetative roof. So cool roof means you paint the surface with a reflective type of paint. Okay, so when you paint with a reflective type of paint, when the radiation falls in, a percentage of the radiation is reflected back. Okay, so then only some heat which falls into the building comes into the building. That the cool roof can be a solution, but I wouldn't say it is one of the best or the viable solution because when you are applying for a lot of reasons. One is when you are applying, a reflective surface, then the heat is the light also reflected on the other side. So if you have buildings around, okay, the heat is reflected into the neighboring buildings. Or if you have other buildings, the light is reflected and there is a lot of glare. Okay, so probably you're restricting entry into the building, but you're still not addressing the whole problem. You're probably shifting the problem to other to glare or to heat and absorption into other buildings. And the other thing is this cool reflective roofs are usually very light in color. So it's practically difficult to maintain the color. It gets dirty very easily. Nevertheless, compared to what we have, instead of having nothing, of course, cool roof is one of the options. A lot of cities think, but in a country like India, where the heat is so much, probably we could look into other options like vegetated roof. So whereas, the heating and cooling, reduces considerably because the heat is not absorbed, we have different layers of vegetation. And that also gives an open space and it reduces the heat island effect. We have seen, if you see into a picture in the summer, the thermal gradient picture, most areas where there is no greenery will look very hot, like orange or red, meaning where they are creating a heat island. Because when heat falls on a concrete surface, it reflects, and that reflected heat enters into the other building. So it's really very hot. But when we have a grass or a greenery or a landscape, then a part of the heat is absorbed, there's not much of reflection, and then there is shading. So overall, if you look into a place, even in a hot climate, the microclimate is affected by the landscape. So because of that, vegetated roof is preferred. So the thermal transmittance or the U value of the roof is one of the very key features. As I said, it's one of the mandatory conditions where you will have to, even if you fulfill all the others and the thermal transmittance of the roof is not fulfilled, then you will not be able to get a ECBC compliance. Okay, because more than 50% of the electricity or heat transmitted is through roof. And the other thing is the thermal transmittance or the U value for fenestration. When we look at windows, okay, windows provide two features. One is it lets light come inside, and at the same time, while allowing light coming in, it also allows heat to come inside. Okay, so if we cannot go for a completely tinted window like a car we have, where we can coat it with the tinted glass so that it restricts heat coming in. If we do that, then we are stopping light from coming in. Okay, so we have to have a value which provides optimum light, because one other feature is lighting loads is one of the main energy consumption. So if we don't depend upon the lighting loads, we have to depend upon natural lighting. We have to let adequate daylight come into the building. If it is adequately lit in the daytime, then energy consumption for lighting load is drastically less. So to tackle this, we have two important terms which we have to look into it. One is called the VLT, or the visible light transmittance. So the VLT value gives the amount of light entering into through the glass. Okay, and then the other one is called the SHGC. Okay, so the SHGC will give you the heat coming into it. Okay, so it's overall single or multi, based on whether it's a single glazed or multiple glazed. The HST factor will also determine to what percentage of heat gain coefficient it can allow. So then, so these three factors, again, the U factor, the thermal transmittance factor for the glass, including the frame. Okay, so if you go for a double glazing glass and you go install it in an aluminum frame, aluminum is a superconductor of heat. So then you're going to still let heat in. So preferably UPVC frame or a wood frame would conduct less heat. So when you do a calculation for a window, you just don't calculate the glazing, you also take into account the calculation for the frame as well. So these days, some glass suppliers are come to give for any type of glass. What is the U? Probably they would not give the U value. They would give the resistance value. From that base, we can calculate the U value, and then the solar SHGC factors is given, and also the visible light transmittance values have been given by the glass manufacturer. So we need to just check to see if the values are good enough. Okay. So if you see, as I said, when light falls in, 57% is reflected, and then 36% is absorbed, and 7% is transmitted. And through radiation, when you see, 22% is radiated outside, and 14% is radiated inwards. So we have around 21% of heat transmission inside the building from outside. Although we eliminate 79%, there's a transmission. So when we see how can we improve the transmission is if we are going to reduce the U value. So we can see here in the ordinary single glazing, the U value is 5.88. Whereas if you use a standard double glazing, then you reduce heat transmittance value to 2.81. And then if you use a double glazing with argon gas, then we reduce it to 2.56. And then the double glazing with the low E, then again. So we can reduce the U value depending by the product we are using and how we are using it. And then, as I said, one other mandatory criteria is in fenestration is that except if it's not a naturally ventilated building space, if it's a conditioned space, all the joints and everything has to be completely sealed properly. Okay. So it gives the criteria that openings between wall foundation, how it has to be chalk or seal, then weather strip seal to prevent drafts, and then exhaust fans will be fit, how it will self-closing damper. So it gives all the specifications so that if it's a conditioned space, then unnecessarily there is no leakage of or transmission of air. And then when we look at the vertical fenestration, as I said, windows not only provide light, it also provides ventilation and a naturally ventilated space. And in terms of to calculate if the room size, based on the room size, if the natural light entering is adequate enough. Okay. We cannot just have a 20 feet by 20 feet room and then keep one single small window and say, oh, then I have a window, but then the natural light. So based now we have come to a calculation to say, depending upon the floor area, what is the window to wall ratio? So we have a term called window wall ratio. So window wall ratio is the maximum allowable window wall ratio is 40%. Because if you're going to exceed more, then more than the light coming in, you're going to let the heat come in. Okay, so there is a restriction in terms of the number given in terms of what is the window wall ratio. So you can stick to, and the maximum applicable allow is 40%. Of course, window to wall ratio will differ depending upon the building type. For example, a theater or a shopping mall will have a lesser ratio because they don't need that much of light, whereas a school building or office building will require at least 40, a maximum thing of 40%. And then the minimum VLT value, the visual light transmittance value as applicable will be 0.27. Okay. When we say 0.27, it means at least 27% of light should be transmitted inside. So then that's a number 0.27. Okay. And then based on the assembly, as I said, assembly U factor shall be determined for overall fenestration, including the sash and the frame. So these three values have been set by ECBC for fenestration. So one is the window wall ratio, and then the visible light transmittance, and then the U factor. And then if you're going to have a skylight, then that is a special criteria. And then, they've given what is the maximum U factor for skylight and for HSGC for skylight, because it will be different. So when you look into window design, so these are the parameters you will look into. Whether it's a window, skylight, or doors, you will look into the thermal conductivity value, then the solar gains, the HSGC value, and then the visual light transmitted percentage. So these are all specified by ECL, ECPC. And yeah, the window parameters again. So what you should do is probably your SHGC value should be less to, you should choose a glass with a lower SHGC and a lower U value. And for daylighting is a requirement. As per 2007 ECBC, daylighting was not a mandatory requirement, but 2017 ECBC, daylight is a mandatory requirement. So the states which have notified the 2007 code in the earlier days don't have daylighting as a mandatory requirement. So for example, Andhra or Telangana, I don't think daylighting is a requirement. But the Tamil Nadu, we have notified after 2017 code, daylighting is a mandatory requirement. Again, as I said, even if the whole building compliance is fulfilling and daylight criteria is not met, then it is the ECBC compliance will not be met. Okay, so another factor we see is in office buildings, when we did a demo, a lot of office buildings failed on the daylighting factors, because although they had complete glass, okay, maybe the VLT factors of the glasses were less, or even if they had glazing, complete glazing from floor to wall, the depth of the building was too much, so that there were adequate 40% for so if you look into a office complex, this comes under business, as per ECBC, at least 40% of the day, floor area should have a UDI requirement of 40%. Mostly because of the depth, if the span of the building is too high, then the daylight factor was not met, even though it complied with all the other ECBC compliance. So probably, I think that's with the building envelope thing. I see someone has asked about whether with the vegetated roof affect the roof slab. Actually, if the weathering proof and the weathering course is done properly, I don't think vegetated roof will affect the roof slab. If you see in a lot of foreign countries, even swimming pools are being kept in the the top floor. That is completely in water most of the time. But if the weathering proof or the sealant is put properly and done, the construction is done without more 50% would be the process of what construction technique you're using, and 50% is depend upon the quality of the construction done. Okay, even if you use a good technique, and if the construction quality is very poor, then probably it will affect. But if the technique is right and the construction quality is up to par, of course, the roof slab will never be affected. Any authorized agency is there to do vegetated roof? I've come across a few advertisements saying they do a lot of vegetated roof. Right now, we haven't authorized anyone, or there's no authorization done anywhere yet. Probably when the code develops and there's a lot of mandatory requirements, when once implementation starts, and when a lot of firms are looking to make the vegetative, because cool roof and vegetative roofs are suggestions given ECBC. It is not a mandatory requirement, whereas the U value has to be maintained is a mandatory requirement. So right now it's in the recommendations is either go for cool roof or vegetative roof. So it's not a mandatory requirement, but over the course I see Bureau of Energy Efficiency is also trying to bring about some schemes to give some tax rebates or some schemes, incentives for buildings which go in for vegetative roof. So hopefully in the near future, we might see more authorized dealers or some incentives for vegetative or full roofs. So, if I think, as I said, if we're going to go into the detailed system, we've covered a bit of lighting and building envelope. Probably tomorrow we can look into the comfort system. The service water heater is less. The renewable energy is not much because what ECBC doesn't give any mandatory to fix any renewable energy at this point. So all it prescribes is that that we have to allocate 25% of the space or 1/4 of the space for renewable energy. The reason being is, as I said, the code is a pathway to net zero. So only if we allocate the space and keep after 10-15 years, if super ECBC or we are going to go to net zero, at that time we will have space for renewable energy. So right now the code says is allocate space for renewable energy and given the standard this much of space has to be allocated. Although the ECBC code states 1/4, in Tamil Nadu, as per the solar policy rule, rooftop policy rule, there is a we have a requirement of 1/3 has to be allocated in the roof for renewable like solar panels. So we have that is like a renewable energy. So because the state rule is stringent, here we follow the state rule. So the renewable energy would be 30 around 1/3 percentage. We have to allocate space for renewable energy. Okay, so tomorrow we can go into a bit more detail on the building HVAC component, water and the electrical components. Yeah, is that okay, Mr. Paramanand?
Yes, madam, please.
Paramanand sir, I'm not able to hear him.
சொல்லுங்க மேடம், கேட்கல.
அவங்களுக்கு நம்ம பேசுறது எதுவும் கேட்கலைங்க சார். அவங்க மேடத்துக்கு பேசுறது நம்ம கேக்குது. அதுதான் அவங்க ஆரம்பத்துல இருந்து 2-3 டவுட் கேட்கும் போது அப்படிதான் ஆச்சு. அதுக்கு பரவாயில்ல, போன்ல சொல்லிருங்க சார்.
ஹலோ.
சரி சரி, ஓகே.
ஹலோ.
மெசேஜ் பண்ணலாமா உங்களுக்கு?
Yeah, sorry sir, I can hear you now. I think my volume had gone down.
Oh, it's okay.
So as I said, tomorrow we can continue with the HVAC and electrical systems.
Madam, tomorrow we have planned for another chapter.
Okay.
With,
okay, some other day, maybe whenever is convenient, sir.
Ram will be coming, right? Ram or Arun?
Arun will.
Okay. Is it okay for him?
Yeah,
for some other day?
Yeah, sure.
Okay.
Some other day, sure.
Okay, madam. Thank you.
So any questions from today?
Venkateshan sir, you had some doubt, right? So you can put forth, sir.
Ma'am, you said that E-star rating is not established in residential building. Anybody holding a commercial and hospitals holding a star rated E-star rating, you know? Anybody holding?
Yeah. Actually, all commercial building star ratings, you can go and check in the Bureau of Energy Efficiency has a website. to showcase all commercial star rating buildings in the state. I think CTS Chennai had long back applied for star rating. This year L&T has applied, VR Mall has applied, and also just for your information, as a state designated agency for Bureau of Energy Efficiency and as a part of building cell to support BE initiatives, every year we take up 4 projects in the state, 4 projects for residential star living and 4 projects for commercial star living, and just assist with the application. Okay. So if you go through a Tangitco thing, if you have a building which you would like to apply for star rating, we provide support in helping do the calculation and application. And this will be submitted through our chief engineer, Tangitco, to Bureau of Energy Efficiency directly. Okay. And recently, this year, to promote, Bureau of Energy Efficiency has given a free waiver for all government, both central and state government buildings. So if there's any government buildings, offices which you would like to apply for star rating, the fees which I mentioned for commercial, which is 1 lakh or 50,000, is completely waived off. So government buildings can get a star rating to create awareness in the state without any charges. And as I said, the application and processing will also be done by Tamil Nadu Building Cell free of cost. So for residential star rating as well, the only thing is the tool is currently not working. Okay. Initially, Bureau of Energy Efficiency had developed the tool, but there were some glitches. Now they have called for a tender and given the tender for redevelopment of the tool. So I'm not sure, they might take applications, but till the tool is ready, I don't know how they will do the calculation and give the award. So the residential star labeling, you can apply, but I'm not sure when the when and how the application will be processed and submitted.
Okay, fine. Do you have any practical data, ma'am, for existing building converted into ECBC compliance before ECBC and after ECBC? How much energy is saved?
Yeah. There's a lot of research on that. For a standard building to a ECBC building, there's a 25% energy saving. And if it's a ECBC plus, then it is 35% energy saving. And if it is super ECBC, it is 50% energy saving. There are a couple of research papers. Maybe next time when I can share it to Paranaman sir, and then he can share it. That 2 research papers, one showing live examples as a study to show that there is energy saving this much of 25% on an average energy saved compared to a normal building. And there is always a question on cost escalation. So if we follow ECBC, the construction cost will be more, it's escalated. So that is also, I think, around 1 to 2% increase in cost escalation compared to a standard building. When you follow ECBC, there is a 1 to 2%. If you go to a super ECBC, there is a 3 to 5% increase in cost escalation. But when, as I said, there's an energy saving of 25% to 50%. So when you look back, the payback period is around 2 to 3 years max. So whatever capex cost invested is returned back in 2 to 3 years, and after that is all profit.
Okay, fine, ma'am. Another one more question, ma'am. Nowadays, people are the inner wall is covered with wood, ma'am. Some mica or wood. Okay. Inner wall. Okay. What will be the thermal transmittance, madam? How it will be best or?
No, of course, how the calculation for wall is, we take into a simple wall assembly. So if the wall is made up of brick wall, then we will calculate the U value of the brick. And then if it has plasters on 2 sides, we'll see the thickness and what type of plasters, then we will calculate. And then if there's anything else added, maybe whatever is the mica, then we calculate. Here, I think because mica is in the inside, okay, it won't affect much the thermal transmittance. Okay, if it is something which is on the outside, then it is going to, for example, there is aluminum on outside. then that will get heated quickly and transmit the extra heat to the wall. But here, this is the thing. So that's why when, for example, if you're going to go for a concrete or a precast structure, okay, then you to comply with the code, you will definitely need insulation. So what we say is the insulation can be done outside or inside. Okay. So if it is an air conditioned building, the preference is given to do the insulation inside. Okay. So that one is the heat doesn't stop there, and also your cooling doesn't go out. But for buildings which are like, not air conditioned, especially for the roof, if you're going to go for insulation in the roof, then we would, the roof insulation, we would always suggest to give it, ECBC recommends to give it on the top. Because when the heat is hitting, immediately you're stopping it. Rather than transmitting to the slab and then stopping it, you're immediately using insulation layer, you're reducing the heat. And also if you give insulation for a roof inside, okay, then probably that is exposed. So you will have to use a false ceiling or something. So the cost might go up. So in terms of recommendation, depending upon the material, sometimes it's inside and sometimes it's outside. But because you said mica is inside, and already we have a ULU assembly, the wall is there and then the plaster is there outside and there's a plaster or something inside and the mica. So the chances are less. In terms of the calculation when it comes to U value, yes. But the way we calculate is we will take the U value will be the thermal transmittance value 1 by R of the plaster. Then we will calculate what is the thickness of the wall, what is the material, that 1 by R. And then again the plaster inside, or if anything else, if there's any wall cladding outside, that is also taken. It's all addition of all together will give the U value of the wall assembly.
Okay, thank you.
If there are no further questions, we can conclude.
Okay, thank you, everyone. I hope it was a useful session. Maybe next week, some other time, probably my colleague and I will do the HVAC and the other part.
Thank you so much. So it's our pleasure having you here, even in the late hours, giving such an insight of all ECPC codes. Thank you so much, ma'am.
Oh, thank you, everyone.
Thank you.
Thank you. Have a nice good night. And
Thank-
have a nice
Thank you.
Thank you so much. Good night.
Thank you, madam.
Thank you very much, ma'am. Thank you.